Rahim, Assalamu alaikum, and welcome to Rahman Digital Production. This is Physics 5054 and lecture number 15. We started the concept of force, and in the previous lecture, we studied the concept of force. Now, in this particular video, we will study the effects of force on motion. What does it mean? It means that if there is no force acting on a body, what will happen? If there is a force acting on a body, then what will happen? So all these things are explained in this lecture. But before going into the detail, ladies and gentlemen, remember that there are certain laws in physics which are of great importance. And in that context, Newton laws plays a very vital role in classical physics. It is said that whenever Newton's invented his three laws, then the whole of the physics is invented. Why we are saying like this? Because it is my experience when I was in the university and I was doing my master degree. Whenever we were proving a law, we always started from the Newton's first or second law. And then gradually we were deriving that law. So everything is derived. Let me share my another experience. One of a professor, which was my colleague, I visited his home one day. So I saw that he wrote Maxwell's equation on the carpet. So I asked him, why, sir, this big? He told me that, Zahur, if I want to derive any law in electricity and magnetism, I can start from these laws and then I will be able to derive that law. I mean that there are certain laws in physics which is having great impact on that subject. So Sir John Isaac Newton formulated these three laws, which is discussing the effect of motion, the effect of force on the motion of a body. In this, the first law is, in the absence of external force, in the absence of external force, a body will continues its motion or remains at rest. Mathematically, we are discussing that, but let me first write the mathematical. Mathematically, this law can be, if F is equal to 0, then A is equal to 0. In the absence of external force, there will be no acceleration. The body will be at rest. Ladies and gentlemen, this law has two parts. One is a body will remain at rest. This is the first law. And that is our common observation. When a book is lying on a table, so if nobody is picking that book, so it means that it will remain there until no external force is there, and that is quite right. The second part of this law is a bit confusing. What is the confusion? A body will move. I am writing forever when there is no external force acting on it. So, ladies and gentlemen, what is the confusion inside this? The confusion is that if we are throwing a ball on the earth and nobody is stopping it, so after covering a certain distance, it comes to rest. Why? Newton is saying it will be in motion forever. But it is common observation that when we throw a ball on the earth, so it will do what? It will remain in motion forever. Somebody asked Newton's that why. His answer was that if you remove the frictional force of the earth, it will move forever. Somebody else said that, okay, if there is no frictional force, in this case, there is no frictional force. What? This one. If we throw a ball upward, it is not moving forever upward because after covering a certain distance, it comes back to the earth. So Newton said that if there is no gravitational force, force is there. In that case, frictional force was there, and in this case, gravitational force is there. If you remove this gravitational force from this, then it will go forever upward. Let me put it in another way, that if an astronaut is going to the outer space and he is throwing the ball there, it will be in motion forever because there is no gravitational force in the space. So the second part is a bit confusing one, but you don't have to confuse yourselves because we are talking about the external, the effects of force. When there is a force, then there will be a motion affected by that force. Ladies and gentlemen, when you are throwing a ball on the earth and if there is no external force, if you remove the resistance from that area, it will move with constant speed in a straight line. It will move with a constant speed in a straight line, and when it is having direction, it means with the constant velocity. So we are having this first law. Now we are turning our focus to second law of motion. Ladies and gentlemen, second law of motion is the most important one because first law can be derived from this second law, and similarly third law can also be derived from this second law. So this law is having a great importance. uh, if a resultant force when a resultant force is acting on a constant mass, acceleration will be produced, and the product of mass and acceleration will be equal to the resultant force, to the resultant force. Mathematically, this law can be written in this way: F is equal to ma. Uh, we can say that force will produce acceleration. If I write this, force will produce acceleration. Whenever we apply a force on an object, then it will produce acceleration. Ladies and gentlemen, a question arises that if we apply a force on the wall, there is no acceleration produced. The Newton's second law is saying that when force is applied, force is directly proportional to acceleration. Force is directly means if you are increasing the force, acceleration will be increased. But if you are reducing the force, acceleration will also be reduced. But what happens when we are applying this force on a wall? No acceleration is produced. This is because of that high inertia of the wall. If we are bringing a crane and then pushing, this acceleration will be produced, but because there is a high inertia of this, we cannot move it. Just like if there is a truck and we are pushing that truck, the inertia of that truck is very much high and we won't be able to move that truck. The second part is also that if we want to write this, so it mean is equal to constant into A, and we said in this particular area constant mass. Ladies and gentlemen, whenever you are removing this proportionalities sign, then you have to introduce is equal to an constant. In this case, The mass will be constant, otherwise the Newton's second law is then not applicable. If you are increasing the force and the mass is also increasing, you are increasing the force but mass is also increasing, so it will never be moving from its place, then the Newton's second law is not applicable. Newton's second law is saying that the mass should be constant. So when the mass is the constant, then F is equal to ma, and that is the Newton's second law of motion. Every law can be derived from this motion. So ladies and gentlemen, this is the second law, and let us do a practical work. But before that, we have to introduce that Newton is the unit of force. Newton is the unit of force. What is 1 Newton? Let me tell you that what is 1 Newton force. 1 Newton force will be equal to how much? When the force is said to be 1 Newton if an acceleration of 1 meter per second square is produced in in a body of mass 1 kg. When we apply a force and we want to know that how much this force is, then we have to see that if an acceleration of 1 meter per second square is produced on a mass of 1 kg. Mass is 1 kg and it is producing an acceleration of 1 meter per second square, then we are saying that 1 Newton force is applied. Because F is equal to ma, m is equal to kilogram, and that is meter per second square. Kilogram acceleration is meter per second square and mass is kilogram. So kilogram meter per second square is also another way of explaining the Newton, 1 Newton. If we are explaining this 1 Newton, so kilogram meter per second square is also the unit of force. Remember my these words. If in MCQs they give us a question that this is there but no Newton is there, and at the end it is written none of them, you don't have to select none of them, you have to select kilogram meter. For example, there is option number 1, kilogram. Option number 2, meter per second square. Option number 3, kilogram meter per second square. And fourth number, none of the above. None of the above. You will say that sir told us that there is Newton is the unit of force, but there is no Newton here. So you will take this, none of the above, but this is wrong. This is also the unit kilogram meter per second square is also the unit of. So you have to select. If it is a tricky question and they want to bamboozle you, then you have to select this option, not this option. That is one thing I wanted to tell you. Now we are turning our focus to Newton's third law of motion. But before that, let me tell you that the Newton's second law, the Newton second law of motion also give us a chance to find the weight of a body. The weight of a body. In this case, W is equal to mg. Remember that in the previous lecture we said that W is also a force with which the earth attracts a body towards its center. So m is this, and acceleration is due to gravity. So you have to replace A by G. This is F is equal to MA. So we will replace this G and this by W. One thing which is a question coming to my mind, and I want to share it with you people. And the question is that when we are weighing our weight on a scale, then when we stand on it, we are saying we are 71 kilogram. We are saying weight is 71 kilogram. Yeah, LB. So is the unit of weight is kilogram? Because when we are finding our weight, we are saying our weight is 71 kilogram. In common life, we are saying like this, but physics does not accept this concept. In physics, W is also measured in Newton, because weight is also a force with which the earth attracts a body towards its center. And G in this case is equal to 9.8 meter per second square. G is 9.8 meter per second. But in your course, they are taking for simplicity 10 meter per second square. So keep all these things in mind, that what is the unit of W, they given you Newton, they given you kilogram, and other. If they are saying the, very important, the unit of force is number one Newton, number two kilogram meter per second square, and third option is saying that all of the above, all of the above. So you have to take this one, because this is also and this is also. So if they are telling you that the unit of weight is kilogram, pounds, Newton, then you have to give the answer according to the topic you learn. Weight can also be measured in Newton. Remember, weight is also can be measured in Newton. Now let us discuss Newton's third law. Newton's third law of motion. One thing which is coming to my mind is there are equation of motion and laws of motion. If the question is saying write the mathematical form of three equation of motion, then that is something else. And law of motion means that this is something else. Newton's laws are three laws, equation are something else, in which we are saying S is equal to VIT plus half AT square. These are called the equation of motion, but these are laws. Let me first explain. Every action has a reaction which is equal in magnitude but opposite in direction, is the Newton third law. If there is a body A and B, this is coming in this way and this body is going in this way. Once they are coming in contact with each other, this body will apply a force which is called BA. Force on body B due to A. And this body will apply a force which is AB. Yani force on body A due to body B. So mathematically we can write mathematically we can write Newton's third law as F B A will be equal to minus F A B. Here I am leaving a question on you people. But before that, let me, if I am hitting the wall with the tennis ball, if I hitting that ball slowly, so it will come very slowly towards me as well. But if I am putting that ball very hard on the wall, then it will come back to me very hard. That is, every action has a reaction. Moving on the earth, when human beings are moving on the earth, this is also the example of third law of motion. We are pushing the earth backward with a force, and as a result, that earth is pushing us in forward direction. So we are putting an action on the earth, and the earth is putting a reaction on the us. Correct. Let me put a question on you. That is what I told you, that if there is a clay with you and you are hitting a wall with it, so it sticks with it. It is not coming back to us. When we are hitting with the clay, that stick to it and it is showing no reaction. So is the Newton third law is wrong? I am putting this on you people. Think on it and write the answer in the comment section if you understood that. That's it for today. Tomorrow we will come with the new concept, new energy. Uh, for that, please subscribe my channel, press the bell icon so you will be informed when I upload the video. Thank you very much. Allah Hafiz.